Hi, welcome back to the Enjermi Channel. The new MacBooks and Mac Mini with the M1 processor are really hot right now. Rumors have that the best laptop of 2020 is the MacBook Pro, and the worst laptop of 2020 is also the MacBook Pro. It's a joke based on the performance gap between the Intel Mac and the Apple Silicon Mac. Let's take a look into what the heck is the M1 chip, and a bit further, what the heck is an ARM SoC, x86, and AMD64 SoC. Let's break it down as simple as possible for everyone to understand. Though it may not work perfectly, let's start off with a metaphor. Let's take a look at cars. The cars that we're used to run with internal combustion engines. It's an old and very mature technology, and it's trustworthy. These cars, which we drive every day, will have some greenhouse gases coming out along with some noise when we start it up and get it up to speed, but once you get on the freeway, it provides a very stable and comfortable ride. The top speed reaches up to 200 miles per hour, thanks to a long history of technical advances, but since it's such a mature technology, the yearly improvement on the top speed is not very impressive. In the recent years, full electric cars, which have only existed in theory, are slowly assimilating with our daily lives. In a way, electric cars function in a much simpler manner than the engine car. If you want 15 miles per hour, just a little juice is given to the motor. If you want 60, maybe a bit more. There's no gas emissions, and compared to engine cars who have a fixed energy requirement, even in low speeds, which come with noise and heat, electric cars have only the necessary noise and vibration required for the speed and provide a much more comfortable ride at lower speeds. The top speed is not as fast as the engine cars, since there's more technical advances to be made, but it is improving year after year at a fast pace. In most of your PCs, there will be a sticker that says Intel Core i5 or AMD Ryzen 3 or such. These stickers indicate that your PC is a desktop or laptop that runs on x86 CPU and system on chip. The x86 architecture, which is more familiar to us, is the equivalent to the internal combustion engine cars in the metaphor. At both low speeds or high speeds, there will be a baseline requirement of power, which transfers to heat and noise from the fan to control that heat. On the other hand, since it is such a mature technology, at running demanding tasks such as games, it can run faster and in a more stable manner. However, because of the fact it's such a mature technology, the yearly improvements of performance is not very impressive. In the phones we use every day, there are processors such as the Qualcomm Snapdragon, Apple A series, or Samsung Exynos. These processors run the ARM system, which is equivalent to the electric cars in the metaphor. Running simple tasks, these processors require less than 1/10 of the power x86 would require, and when the tasks become more demanding, it would heat up and require some cooling, but not as much as x86 architecture would, since there is a limit to the complexity of the tasks you can do on a phone. Since this is relatively novel technology, it does show steeper improvement yearly in performance, but since ARM was originally designed to run less demanding tasks in a low power environment, the top speed probably won't be anything close to the top shelf players in x86. Let's take a look at the benchmark history of the Apple A series, who are currently leading the field right now. Okay, this is shocking. The system designed for very limited circumstances is already overtaking the very best of the PC processors. Looking at the rate of improvement, you might even guess that in a few years, nobody will look to Intel or AMD anymore for their systems. The American business academic Clayton Christensen introduced the theory of disruptive innovation in 1995. Warning to college students, we will commit the academic sin of sourcing Wikipedia. Here goes. A disruptive innovation is an innovation that creates a new market and value network and eventually disrupts an existing market and value network, displacing established market-leading firms, products, and alliances. In low-end disruption, the disruptor is focused initially on serving the least profitable customer who is happy with a good enough product. This type of customer is not willing to pay premium for enhancements in product functionality. Once the disruptor has gained a foothold in this customer segment, it seeks to improve its profit margin. To get higher profit margins, the disruptor needs to enter the segment where the customer is willing to pay a little more for higher quality. To ensure this quality in its product, the disruptor needs to innovate. The incumbent will not do much to retain its share in a not-so-profitable segment, and will move upmarket and focus on its more attractive customers. After a number of such encounters, the incumbent is squeezed into smaller markets than it was previously serving. And then, finally, the disruptive technology meets the demands of the most profitable segment and drives the established company out of the market. Since the terminology comes from the business world and not the tech world, the idea does not exactly match the evolution of the A series perfectly. But if you substitute product quality with processing power, and segments of market into segments of processor lineups in Intel, you can see a strong correlation. The performance of Apple's ARM chips are already close to Intel and AMD, if not better. And looking at the rate of improvement, it seems that the gap between Apple's ARM and its competition will grow to an impossible level. Apple's M1 chip for PCs, from its ARM technology, fits the definition of a disruptive innovation. Of course, ARM technology comes with its limitations. Extremely simply put, compared to x86, ARM has compatibility issues. You cannot run iPhone apps on Android, and if you want to run Android apps on your PC, you will need emulators which are capable of using only a small fraction of your PC's processing power. It's like you can't pump gas into your electric car, and you would need a generator converting the gas into electric energy you can plug in, which will be terribly inefficient thermodynamically. The options we have when we want to run x86 application on ARM are either emulation or redeveloping the entire program for ARM, like giving electricity to the electric car in the first place. For the device manufacturer, it is very difficult to let out a product in a market where there are no applications available for the system. Microsoft actually released an ARM-based device in 2019 ahead of the 2020 Mac, the Surface Pro X, and it faced huge criticism that nothing is available to use due to the compatibility issues of ARM. However, there is enough reason to believe that Apple's M1 can overcome this obstacle. First of all, the level of emulation is amazing. Many tech YouTubers testify after running x86 apps on the M1 that the performance is almost as good as Intel or AMD systems, if not better.
Now, I want to move this conversation onto what I feel like is the more important testing. How do non-native apps run on M1, right? Because the vast majority of apps out there are still not optimized for this type of hardware. And here's the thing. I've had experience with several companies that have tried to make ARM-based chips that run non-ARM-based software. There's emulation involved, and usually it's not great. So I had very low expectations, right? I fired this thing up, and Adobe Premiere, this is again an application that was written for x86. It's not optimized right now, and it runs weirdly well, like so much better than I thought it would.
And for the ARM local apps like Safari, Final Cut, Logic, which are fully optimized to use the full power of M1, are insanely fast. And it seems that we won't need so much emulation in the near future. There are huge application makers for productive apps like Microsoft, Autodesk, or Adobe, or developers of consumptive apps like games. If it's the Surface Pro X, which has a loyal yet limited fan base, it is difficult for these developers to redevelop the plethora of applications they have for ARM. But when Apple, who has the biggest fan base out there, switches to RAM, it has a very different story. Adobe has already released Lightroom for M1 and have announced that most of their programs will be available for M1 by 2021. If you check Adobe Creative Suite, the beta versions of most programs are already there, and this video you're watching now has been produced on the beta version of Premiere Pro for M1. In the world of games, Blizzard has already released World of Warcraft, and Riot Games has released Legends of Runeterra for M1. As those of you who watched my Google versus Apple video may be able to guess, I'm not a person who likes Apple and their products. But there's so much evidence to believe that the M1 chip and the Apple Silicon products that will follow really fit the definition of disruptive innovation. Of course, I see Intel, AMD, Qualcomm, and Samsung developing ARM systems to compete, but in my opinion, I don't see them reaching the level of performance of Apple for a few years. Just like when Apple first released the iPhone, let's face it, Android was terrible. I expect history to repeat. Even though I hate Apple so much, if the conclusion comes to this, well, I guess I should board the hype train. In the near future, we'll come back with a real-world usage report from someone who has basically never used Macs. Thank you very much for watching. Please like and subscribe to help us in continuing our story. For those of you who have already subscribed, we would like to tell you that it really does help. Thank you.